second. Yes, we are recorded.
So dear colleagues, welcome everybody to this session of our online game theory, mathematical game theory seminar. And it's a great honor and pleasure to welcome our speaker today, Itzhak Gilboa, who is from Tel Aviv and Paris and from the East Coast. I think not too much need to introduce him because he's a prominent person in decision theory, game theory, and economic theory. Excellent papers, series of papers, and many papers, many important ideas and thoughts and contribution to these fields, and he's also a hub or a very central person of hub of decision theory in Paris, annual DT conferences or workshops. So he's very famous for many reasons. And today we can learn a lot of very interesting thing from him, because he will speak about that. Were you thinking decision theory as coherence test? So Sakidi, thank you for accepting our invitation, and the screen is yours.
Thank you very much. It's a pleasure to speak to the forum. Thank you for clicking. So when I was young, I used to start out with a big introduction of why am I doing all this? And by the time I got to the results, people said, oh, this is so underwhelming. You started by talking about what are we doing on Earth, and then you ended up with saying that 2 + 3 are 5. So I'm trying to be more careful about that, not to do that. I thought this was, I'm sorry. Can you hear an echo, or is it okay? It's okay, only I hear it. Okay, doesn't matter. I mean, it's fine because I'm with 2 screens. Over the years, what also happens, I guess, is that ideas become bigger, that the results become smaller. So what I'm going to present here are very simple results, but I'm going to talk a lot. So in order not to oversell too much, I'll start with the results. I'll try to basically mention 2 papers. One is a paper with Larry Samuelson with this title, What Were You Thinking? Decision Theory as a Coherence Test. And then I'll try to zoom out a little bit, talk about the bigger project. And then some other things, and go back to another paper with Larry, Andy Postlewaite, and David Schmeidler. And they're just discussing ideas. I don't think I'll get much into the formulas because probably it's going to be too short a time for too much notation and relatively too few results. So let me start with this specific paper with Larry. What were you thinking? So let's assume that we have a situation. We're thinking about the protocol for decisions that are supposedly transparent. We're thinking about someone who makes decisions for others. Okay? So in particular, it could be a politician who we appointed and making decisions on our behalf in a presumably democratic society, or it could be a fund manager who's managing your money or something along these lines. And we were thinking about a protocol of interaction in which the person might be asked, software these days especially, might be asked to defend their choices. So they make some choices that matter to us. It can be politicians' choices, COVID, shutdown, no shutdown, or the fund manager who makes investments, or maybe going even further. And they should be able to say why they made these kind of choices. So the what were you thinking is the kind of question that we can ask, especially, of course, if we're unhappy with the result, but we want to imagine a situation where when they make the decision, they sort of think about being able to defend their choices. And sometimes it could also be something we'll want to do ourselves. Okay, so if you read a little bit of the psychological literature and we say, oh, maybe we're prone to these kind of biases and mistakes, so maybe it's not a bad idea for me too to be able to, before I actually make a decision, ask myself, how would I defend this decision if I had to, if my future self would come asking me, what were you thinking? And the kind of things that I might be, or maybe I was just making reasoning errors or kind of psychological errors that I've seen people are exposed to. Maybe my beliefs are a little bit strange. Maybe my utility function is not exactly what I'm telling myself it is. So it could be many questions that if I'm trying to support my decision, let's say even standard expected utility, I might have to ask myself what kind of utility function, what kind of beliefs are needed to justify. Here in this paper, we're dealing with a very simple version of the paper because of the question, because that's where the relatively elegant results, not very complicated, but at least crisp. So we're thinking about a decision in which the outcome, the possible outcomes are known, the utility function is known, which is big assumptions, of course. We'll also assume the states of the world are known, and as I'll explain in a minute, we are also going to assume that the decision maker needs to specify some like a certainty equivalent to each act, to each possible choice in the act that they're going to choose. We will do this exercise for two models. One is the standard Bayesian one, then something non-Bayesian, and the simplest one to analyze for us was the maximum U. And in both of those, we want to ask which collection of decisions, given this protocol, and in particular, I mean, we assume the utility, we assume the state of the world, and we assume that the decision maker, when they're asked to make a decision, they have to write down for each option what's the certainty equivalent for each option, and then presumably pick a maximizer. So which collections of such decisions can be justified? First in the Bayesian model, secondly in the maximum. And feel free to interrupt me if there are any questions or comments along the way. Before I present the simplest result, I want to mention that the kind of question we ask is actually very similar to what's been asked in revealed preference theory. Okay? Because in revealed preference theory, think of something along the lines of, say, Afriat famous theorem. You have a collection of choices by a decision maker, say a household who selects among bundles or picks a bundle as the budget set. And you ask, when is there a model that can justify it? Okay, so in the case of Afriat, when is there a model class of utility maximizing models? When is there a monotone utility function that can justify all of those? So basically, it's the same kind of mathematical question we ask. So there's a collection of decisions, choices made. We're thinking about them as a finite set, because thinking about a finite database of decisions. There is a collection of models on the other hand, and the question is, which databases of decisions can be justified, can be explained by one of the theories in this collection of theories. So that's simple exercise. I want to emphasize, though, that even though the mathematical question is the same, our motivations are quite different. Because real preference theory is basically what I'd like to sometimes call second-order theory, in the sense that this is a theory describing the work of the economy. Okay? So, for instance, let's say that I'm taking Afriat theorem. You might see some pairs or something. So let's take Afriat theorem as an example. So the theorem says, okay, we have a collection of choices, in this case, bundles chosen out of budget sets. And the question is, when is there a utility function that can justify this? And then the result that says it exists in this class, that class, okay. But the kind of thing that Afriat does is actually modeling not actual economic choices alone, but the work of the economist. So we can imagine an economist who's observing a household. The household is making real economic decisions. The economist is observing the household. Afriat comes and observes the economist. Okay? And for the economist, there are theories like utility function and real data. In Afriat's model, both are formal entities. So there are the utility functions remain formal entity. They start as a formal entity, they remain so, but the data, which are real data for the economist, appear in Afriet's model as formal objects. So in this sense, it's almost, like, philosophy of economics or sociology of economics. It's the work of a social scientist whose subject matter is the work of the economist. In this sense, I call it second order. By contrast, what we have in mind here is actually first order. So we're thinking about, you could be the prime minister making decisions about lockdowns or something like this. So there is an actual decision that's being made, and the emphasis here is much more normative than descriptive. So in the previous kind of interpretation, we're thinking about Afriet saying, oh, this economist would succeed in explaining these data sets if and only if something. He's sort of observing this from the outside. So it's second order and descriptive, while what we're doing is first order and normative, because we're trying to say these decisions can be made and are coherent, we pass a coherence test, and these would. And this has implications on the kind of data that we assume. So in particular, when I said at the outset that we're going to assume that the decision maker for every problem and every one of the alternatives will have to specify the certainty equivalent, I'm not sure this makes a lot of sense if I'm thinking about a descriptive model in with preference theory. Also, typically we just make choices, not write down what's the equivalent of choice, certain uncertainty. But I can afford to. Okay, so if I'm saying, okay, now we're setting the rules of the game, we're going to have a prime minister making all kinds of decisions. Let's try to set the rules for what kind of decisions want to be made by our appointee. And then say, okay, I'm going to insist that they write a protocol in which they say, well, what was the certainty equivalent of each possible choice? And then they should choose a maximizer, and I want them to put it on file, just like they put the minutes of the meetings. So this changes a little bit the kind of data that we assume. Having said that, some results that are in the revealed preference theory that are close to ours in terms of justifying decisions under uncertainty with Bayesian and non-Bayesian models, in particular Polisson, Kwai, and Renou, and supported by Chambers, Chimica, and Sato. So they differ somewhat from our results, but not exactly the same question, not exactly the same answer, but it is related. Questions, comments? Okay, so the framework we're going to use is the following. We're going to assume finitely many states of the world. So S is going to be a state, up to cap S. Acts are going to be indexed by lowercase a. And having said that, we are going to assume utility is given. So acts are going to show an act. This thing over here. So XSA is the outcome that act A yields in state S. So the data that we are given is basically, these are the possible choices, basically a matrix of payoffs. And because I said we're going to demand this, we're going to have a certainty equivalent for each. And the question is, given such a matrix of X's and a vector of C's, when can it be justified? And the question is, of course, what is justification? So let's start with the Bayesian one. So the Bayesian justification would be the case in which our decision maker, when they are asked to say, okay, what have you done? What were you thinking? They have to say, oh, this is what I was thinking. I was having a probability in mind. Okay? So if that's the case, this is what defines a justification. Okay, justification means that there exists some probability over the state space such that all the numbers I've given you, all the valuations I've given you are exactly the expected payoffs. Expected utility, assuming that we have the utility. And the result, which is pretty straightforward and in a minute I'll say it's also something that you've seen more than once in your life, is to say that this is equivalent to the following, that there is no collection of coefficients, which would be positive or negative, such that if I take the average of the acts, it strictly dominates the average of the valuations. So here I take the C at each and every point. So this I refer to the C also as a constant. Here it says also or, just the opposite, and since the lambdas are unconstrained, then what's written in both of them is the same. Don't really need the or, but I leave it here in this way because it's going to be useful later on when we move to the non-Bayesian. So basically, it says there is such a probability if and only if you cannot find some combination of the assets that is completely dominated by the combination of the values or vice versa. And this should be reminiscent, it's almost identical to what's called the fundamental theorem of finance. So if we think of an act as financial assets, we have an act with known utility values. So say this is just money and I care about expected value. Then this is basically what it says. Okay, so the fundamental theorem of finance, we'll go back for a second, basically says that there is no arbitrage, namely there is no way to combine assets. So now think of the C as the price of the asset in the market, and the fundamental theorem of finance would start with 2 and to say there is no way to combine assets such that you make a sure profit at each and every state of the world, if and only if there is some probability such that each asset is valuated by its expected payoff. The formulation typically there is a little different in terms of weakness and strict inequalities, but that's sort of minor. We get there from completely different angles because we started by asking when is a Bayesian justification possible, and this is what we got is this sort of no arbitrage condition. For the fundamental theorem of finance, the linearity of the payoff is trade is given, so part of the mechanism of the market. No arbitrage is an equilibrium condition, and then the probability comes up as the, so to speak, the probability of the market. But of course, it's both are characterization results, so it's an if and only if. It seems to us that this coincidence, I mean, this kind of equivalence would break down once beyond Bayesian to non-Bayesian, but as it stands, it's quite similar. Oh, sorry. We'd like to think of the theorem as sort of describing a debate game. This is a little bit related to game theory, and actually the simplest result that we have is also maybe basically max-min. What do you mean by debate game? So imagine that just continue with this kind of interpretation. There is the decision maker who's making decisions, say for us, whether it's our money or whatever. And the player 1 is the decision maker who needs to be able to justify the choices. Player 2, this is us, we're coming and complaining. We are the skeptic saying what you've done makes no sense and we don't like your decisions. So let's think of 2 games here. One game is to say, okay, the decision maker is okay, she wins, if she can point to a probability that simultaneously justifies all of her valuations in all the choices. So we could have here many different decision problems. In each decision problem, there were several possible acts. Each and every one of them, there are these protocols. We open up and we see exactly what she thought was the certainty equivalent of each possible choice in each possible problem. And there is one probability that she can point and say, you see, it gives us all the answers, so therefore she won. Debate game 2 would say we're coming to challenge her choices, and in one case, for instance, if we see, go up for a second, if I find a point over here when she evaluated something at let's say there's only one lambda, just 1 and the rest are zeros. So I found an act that she evaluated as higher than its maximal value. So obviously, what were you thinking? I mean, no probability to justify that. And this sort of generalizes this and says, with any combination of those. So if I can find a combination of these values that pretty dominates coordinate by coordinates, the corresponding combination of X, I say she can't explain this. Okay, so I won. And the theorem basically says that these two games are good. If we let the decision maker win in case she can find a justification, or we let the skeptic win in case the skeptic can point to such a combination with the lambdas, then we're describing the same game. And what's so sort of nice about this is that it's quite simple. It could be also proven by the Max-Min theorem pretty easily, just by taking take every state, define to excess valuation or undervaluation, and basically the lambdas here are unconstrained, and so we have to separate the positive and the negative and normalize them, but basically it looks like a probability vector. For player one, these are anyway probabilities, so it's basically Max-Min mixed strategies. By the way, it has a sort of cute geometric interpretation in two states, which is quite misleading in many ways. The reason that the case of two states is special, following reasons or two. First, of course, you can see this, but also there's only one parameter. If there's only one parameter, then if you give me one valuation, give me an asset X and its valuation C, there's only one probability that can justify it, assuming it's non-trivial. And then if any two valuations are coherent, then all of the set of everything is coherent, which is not going to be the case in most states. So in this sense, it's pretty special. But it's sort of cute still because it's basically just Taylor's theorem. For instance, well, maybe I'll look first at this left one because it's going to be something that we're going to use later on. So what's going to be ruled out, for instance, is that there are two states, and you have one asset here, and you value the 1, 0 by 0.4, and you evaluate the 0, 1 by 0.4. And as you can imagine, I would like to say later on that maybe this makes sense if you have ambiguity about it, but without ambiguity, you can't explain this, and this would be see this in the theorem by taking the 50-50, and you say, well, the 50-50 of the assets gives us 0.5 for sure, and the 50-50 of the C's gives us 0.4 for sure, so this one dominates that one. Okay, so that's sort of one way to look at it. Maybe just to see Taylor's theorem, suppose that you have some asset XB that is evaluated by CB over here. So C is of course just the number, but we think of it as a constant, so it's on the diagonal. And X is valued by C over there. And I want to argue that these two segments have to be parallel in order to satisfy our condition. So if there is the condition that this skeptic is looking for the lambdas, is trying to prove that we are wrong. So in particular, the skeptic can come up with lambdas and weighted average of the x's that we put the weighted average over here in the certain mixed weighted average. If we take the same weights for the c's, it should better be the same point, because if it's too high, we could say you overestimated or underestimated. It is what the condition says, that if for the same lambdas, we cannot have the c's above or beyond, above or below. So the same lambdas that give us the average over here for the x's would have to put the average of the c's over here, which means that the ratio of this to that is like the ratio of this to that, but not equal. Okay, just proportional. And if they're proportional, then we have Taylor's theorem that says that this and these are parallel, and if these lines are parallel, then it's the same probability. And basically other cases are the same. But of course, this is only for two states, and beyond this we need more. Relationship to the Finetti. The Finetti's derivation of subjective probabilities was under the assumption of expected value. working for an insurance company, but the model there is sort of a single risk neutrality. And what he did was to think about acceptable and unacceptable acts or bets. So if every vector in RK or in higher space, high dimensional space, is either acceptable or not, basically assuming that the set of acceptable and set of unacceptable are each of them is a convex set, a little bit more, and then separation, and that's where you get the probability. This is sort of equivalent to an axiomatization in which we imagine that we can make choices between any pair, so we have a lot of data. And by contrast, what we are doing here is to assume only a finite collection of cases, because we're not trying to say that the decision maker necessarily has to tell us what she would have done under any possible circumstance. We just look at the actual decisions that she had to make. She should maybe foresee this and ask herself what kind of decisions I can now make would still be coherent with those I haven't made in the past. But she's not supposed to necessarily give us a complete relation or something like that. Okay. So I do want to go beyond.
Sorry. It's okay. Sorry. So I guessed before your slides that the definitive will be something like disintegrability or something. So your results will be related to the notion of disintegrability or this conglomerability. So I mean that because this kind of alternatives, theorem of alternatives, we can see in many places.
Yeah.
And somehow you can say that either you have your price vector can be seen as a prior distribution over the states, and you could say that either you have this prior when you don't have money pump, or if there is no money pump, that is everything is fine. But if it is not fine, then it means that there is a money pump. So this is acceptable or unacceptable, but I don't know. So it is also true that your theorem, your alternative, is also related to this. So sorry,
Right.
So I interrupt myself. So everything you push in a setting when there are utilities, but I guess that you can get rid of the utilities and you can show something very similar in general.
Well, I'm not sure if it's going to be very similar. So this is a little bit what the results, Paulson and others did, and also Chenicke. There it's what you do, you get something like the Friat kind of condition. There will be no cycle of this type, okay, or the stronger axiom of Wild preference, that you cannot have a finite cycle of preferences of this type, which is a little different from what we do here. But that's the kind of thing that I think exists for now with utilities. Because if you have both utilities and probabilities, you don't have all the elegant tools of separation here. So in this sense, what we're doing is going to something that's in some sense cute. But if you want to tell me it's not completely realistic, I'm fine.
No. I mean that perhaps one can interpret your results in a way also, so in a different way, but it's not better or something that you can define the notion of something is fine by this theorem. So you when you presented your results, you said that if somebody is right, then this holds. If she is not right, then the other alternative holds. But perhaps you can say, look, I define the rightness by this theorem. So something is good or useful to describe the situation if there is no, the second branch, second point doesn't hold, because I would like to use to something which is not good in that model if it holds. And then you can define practically, it's not a mathematical definition in a sense, it's a normative as you mentioned, but am I right? So you have in mind this kind of judgment of the different branches of this theory.
Absolutely, yeah.
Okay.
And that's why I want to go back to this example here, the non-Bayesian one. I'm sorry, I skipped this. Okay, I wanted this one. So I want to go back to this one, and suppose that now you have this, the politicians making decisions based on thinking about climate change 20 years hence, and we all agree that climate change is a phenomenon that's here, but there's a lot of variation in terms of probabilities. And there's papers that look at different, do meta-analysis on what are the probability of a certain increase in temperatures in a given spot. And you look at the person and say, look, I mean, I really don't know. I don't have a single probability. So you look at the kind of decisions I made, and yes, I evaluated this thing here by 0.4 and this thing here by 0.4, but that's because there is real uncertainty, and I think that your condition there is too strict. And if you insist that I explain all my choices by a single probability, then it might be very silly to. I might be able to find it, but maybe that's not what you want, because I won't be able to. Scientific studies will not give me a single probability. So let's think about a different kind of justification. And for instance, let's admit that there are certain probabilities we don't know. So here, the max mean is just the simplest thing to do. It's just so we do the same kind of question asked about the max mean. And what we're basically saying now, okay, so you as the decision maker, in order to win the game, you could do a bit more, because now you could have a full set. And this is what's called the justification. Okay, so obviously you could still pick a singleton if this works for you, but even if not, you could pick a set. Naturally, this means that it's going to be harder for me as I'm the skeptic. And I want to show that you've done something very silly. So here it's going to be harder for me to do it. So we take only the one side of the inequality. So earlier they were the same because things were not constrained, but this time you need to be able. So I'm generally going to be okay with undervaluation. So I'm going to be relatively lenient with you, as in the case of the 0.4 for the two things that are 1001. But I'm going to check your overvaluations. Okay? If the lambdas are all non-negative, then this is a wild overvaluation, of course. Say that I caught you right-handed, but even one negative. Okay? So the condition that identifies this now is to say that there is no act A tilde and no collision of coefficients for the others. For everyone that is non-negative for us, such that this thing. So that's just a different debate game now. We just changed the rules a little bit, allowing more freedom to the decision maker. Then naturally this means that the skeptic is a little more constrained. The proof is not too complicated, but it takes steps. On the geometric interpretation, I'll just say that it's even more special this time, because with two states, not only we have all the constraints we had before, but also a set of probabilities is only an interval. So you're either justified by this point or that point, but generally, once you go beyond this, a set could be infinite parameters. But maybe I'll skip that picture, try to now wave my hands a little bit and oversell the results. And then I'll go back to the other issues. Unless there are any questions or... Okay. So this theorem, we believe, is not extremely deep or difficult, but it's, we believe, at least a new theorem. What's the bigger picture here? Well, we're looking at decision theory, and at some point, the question is, what is it good for? And especially if you come in touch with people in the business world, like MBA students, maybe it's not exactly the business world, but this is as far as I get to in touch with the people in this world. And they can often ask, who needs that, okay? And they have an incentive to normal, expected of students. They have an incentive not to study, and they have very good reason to say that there's decision theory is useless for them. Because either it's something that works perfectly fine, and then it can be programmed, or else it's something that depends on your intuition, and then it doesn't get into the formulas anymore. So, some of the big successes, for instance, would be something like Waze or any navigation application. And I think that this was perfectly in line with the image, the forefathers had this idea in the 40s and the 50s. They just want to mathematize everything. We have an objective function, we have constraints, and we do statistics to find out what's needed. And then we just use some algorithms to find the optimal solution. You know, it's operations research, game theory, decision theory, micro, all of these together, and we get the answer. And if your phone tells you that the shortest path from A to B is to go left, you just go left, and that's wonderful. It's a great success. But just because it's such a great success, you just program it once, you don't need to study. And then, there are other questions in life. Someone can come to me and ask me, how would I invest my money? Decision expert, how would you invest money? My answer is, look, if you have money to invest, you probably know something I don't. How would I know what to invest your money in? So many uncertainties and so on. So it seems like the answer is, okay, in other questions that are not programmed on a phone app, then we just don't know, and it depends on the intuition, and the models are useless. Now, as someone who's in the field, obviously I have a vested interest to argue that this is not the case. But I honestly believe that it's not the case, in the sense that I think that there's a lot of ways in which decision theory can be used. And I'd like to think about it as what we're having is sort of a dialogue between the decision maker and decision theorists. And this dialogue can be on a whole gamut. There's one extreme, the decision maker says, I have a problem, I want to get from point A to point B. She relegates the problem to the decision theorist or even software and gets the answer, and that's it. Okay, so this is a very one-way dialogue. On the other extreme, you could think about just the opposite, that a decision maker is about to make a choice about investment, about a career choice, about big problems of nations, involving wars or personal problems. People are getting married and divorced and choose careers and change careers. And they come to ask and say, what's the right answer? And I say, yeah, what's the right answer? I know. But I might still help you think about it. So tell me what you feel like doing. Okay, you're about to make a decision. Now let's sit together and construct a decision model that's going to support this decision. Okay, so it's a kind of what were you thinking kind of question. Suppose that your future self, someone, comes and says, okay, why do I have this feeling? So let's try to construct the simplest model that would explain it. And we'll see what kind of probabilities, what kind of utilities are needed to be put in order to support this decision, and see if you're comfortable. You yourself, it's your decision. Okay? So this is on the other extreme. So in sort of popular paper with Siboni and Ruzio, we call it decision theory between software and the therapist. Software meaning, something like Waze. You send a problem to the software, you get the answer, you can argue. The other one is this therapist, where you're sitting there in a clinic and you say, this is what I feel like, and the therapist is trying to help you understand what it is that you really want. And in between, there's a whole gamut, and there's a whole exchange that's possible. One thing that seems important to us in this is to say, well, the language of the dialogue can be relevant. So if you are about to make a decision about a career, and you ask someone, what should I study? And trying to think about what can happen, which professions are going to exist in 10 years from now, maybe it's very difficult to put probabilities on that. All of a sudden you have ChatGPT, and it turns out that maybe we don't need so many programmers as we used to, things like that. So who knows? So if we offer models that are not necessarily very comfortable, very that fit the structure for the decision maker, then they might not succeed. So here we're trying to say that the language or the model should be also part of the dialogue. So if your decision maker is unhappy with a certain model, and says probabilities can be specified or something like that, then you say, okay, let's try another one, for instance, Bayesian. Or let's try something completely different. It depends on most states of the world or whatever. But in this sense, it's a good thing that we have a proliferation of decision models, because different decision makers might feel comfortable with different models, which is not exactly the same case in economics, because if you think about decision theories serving economics as providing tools for economic analysis, then there's so many tools that economics can change in every so often and starts all the analysis afresh. But if you think about actually helping people making better decisions for their own decision making, then the proliferation is not there. Here we found this reference to Laplace. Now I hope there's no Laplace expert in the audience because I'm not sure that my interpretation is precisely correct. But I'm going to say that this is exactly what Laplace had in mind. We could always select with the help of this theory the most advantageous choice on our own, refreshing supplement to the ignorance and feebleness of the human mind. It's 1812, way before behavioral economics. Just thinking about the public utility that rests on the theory. And if we observe that even when dealing with things that cannot be subject to this calculus, the theory gives the surest insight that can guide us in our judgment, teaches us to keep ourselves from the illusions that often mislead us, we will then realize that there is no other science that is more worthy of our meditation. So I hope that this is not too far from what's in mind. But this is part of the semi-political agenda of saying that we should have a decision theory that's useful for public people. Any questions or comments? I'm sure that you all agree with me, so comes to the ideology, of course. But what I'd like to do now is to discuss this other paper with, this is joined with Andy Postlethwaite, Larry Samuelson, and David Schmeidler, in which we actually wrote a formal model, very cumbersome, inelegant model that was supposed to show analogies between 4 different distinctions. And some of it are relevant to game theory more than others, so let me talk about these. And I'll try to say eventually in this 15 minutes, what are the 4, so there are 4 distinctions. One of the last one is what we just discussed. So I'd like to cover briefly the other 3. They would seem unrelated. And later on, I'll try to say there is some common structure, in some module at least. And the 4 distinctions are the following. One is what's the role of models in economics? So the 2 distinctions there. Something, theories and paradigms. What are we doing in particular in game theory? Is it a theory or not? 2 notions of rationality, and finally the 2 ways that. So let me start with economics and what economics models are doing and what are they good for, and things that is asked, but maybe more since 2008, extended sometimes asked by students in class in undergrad. And there is a classical view of science that says, well, if we have scientific studies, we can predict, we can learn to predict, and then opens the door to questions such as, so why didn't you predict 2008 or things like that? And we have our excuses, and we say things, okay, we haven't figured out everything, we're making this work in progress. Thinking about financial crisis is a little bit like thinking about seismology or meteorology. Okay, earthquakes are difficult to predict. Weather. And sometimes I like to tease physicist friends and to say that the way they kept physics so clean is by saying this is not physics. So they pushed, seismology, meteorology, decided are different disciplines because they figured it out. Of course, we haven't figured it out, but also they're not dealing with chaos problems, even though these are problems that matter to us. There's the extra difficulty that we can only predict equilibrium more or less by definition. The hurricanes and earthquakes don't respond to the theory, and people do, etc., etc. But there's still this approach that we should predict, and we're not always so great at that. There is another paper that the 4 of us have written that to say that part of economic models, or one way to think about economic models, is as cases and not as proofs. So if we think about something like, suppose you take an ultimatum game and you solve a subject of equilibrium, and then someone shows you an experiment, an ultimatum, and say, oh, it refutes your theory, and we're not so troubled by this. And many people around us in other disciplines ask, how come you're not troubled? And what we try to argue in the the previous paper is to say, well, part of the way that economists think about models is as a case. Like there is no universal quantifier that says whatever you see something, it looks like ultimately this will be the outcome. But here is a case that I solved, theoretical case I solved on the blackboard. You might have also an experimental case that Donald Guthrie have. Now, when you see a real case, ask yourself, which is it more similar to? So this was another paper trying to explain why economists are relatively happy with their models, while the rest of the world thinks it's nuts. But it was still about predictive science. We're still saying the model is used to predict things, only the prediction is not by a universal rule, but by analogy to cases. What we want to suggest here is that there is a completely alternative way to think about it, and this is to say the job of the economist is just to sit there and raise their hand when something really silly is being said. Anyway, politicians and journalists are saying all kinds of things, and the economist is not there to provide prediction. The only job that she has is to wait there, and when she hears something really stupid, to criticize the outcome. And the critique could be logical, maybe something is just non sequitur. It could be an economic reasoning, like you say, that's very nice what you're describing, but it's not an equilibrium because at equilibrium something else would happen, or to test the data that people are quoting. And so in this sense, we try to argue that economics has a role, even if it doesn't predict at all, because actually so does history, right? I mean, most historians would say we're not in the business of prediction. We don't have crystal balls, we're talking about the past. And yet, most of us believe that we should study history. And one way to think about it is to say, well, someone who has studied history is going to be a lot more would have a much more astute criticism, would be aware of all kind of reasoning, things that others would not. Maybe economics has this role to some extent. So we have these two roles of economics. One is a predictive science, trying to say, yes, this is what we think will happen. And another one is just critics say, well, this I don't think. So let me put it on the shelf for a second, and let's go back to the questions of theories and paradigms. Now, paradigm is an overused word, so if you don't like it, use something else. But I want something more general than theory. And with theories, we have concrete examples. Paradigms seem to be much more flexible concepts. Okay, so in our case, we use so decision and game theory. We have terms that are quite open to reinterpretation. For instance, we have a decision under uncertainty, when we have an alternative, then we could put more into an alternative. Even something like the ultimatum game, show me that someone didn't take a low offer. And say, yes, it's not only money, because part of the alternative are emotions, feel about it, pride, or things like that. Also, when you think about the decision under uncertainty, there's a lot of freedom in defining the state. There always bigger uncertainty here. We can think about more time periods. When we're thinking about game theory, we have a lot of flexibility in the choice of what is a player and what is a strategy. Even a player, if I ask you, for instance, consider these, you're a game theorist, tell me what's going to happen now in the war in Ukraine. Trying to analyze it and say, okay, maybe the US is a player, maybe someone said, no, that's oversimplified. You have the president and you have Congress and you have these are the players. And maybe someone else would say, no, but you also have to add time periods, etc. And this has to do with the question of are these fields, what I guess most of us are doing most of the time, decision game theory, are there theories that are replicable or not? So, and then it mentioned here the ultimatum game, which we obviously can easily explain away by saying, oh, just put more things into the outcome. Many framing effects can be explained by putting in information considerations. The very fact that someone framed it this way gives me some signal. For instance, changing the default tells me something about what people do in society. Maybe there's a signal to be learned from that. We won't go into all these examples. So it seems that in some sense, they are not concrete theories, We also don't think that they're completely vacuous. Okay, so in a book that David and I have written years back, we call it conceptual framework, in the sense that the framework has some elements, such as players, strategies, etc., but there's a lot of freedom in mapping them to real-life objects, deciding who are the players, what are the time periods, what are the uncertainties. And in this context, there's the question of repeatability. I'd like maybe to stress that I think it does say something. For instance, Dave Krebs has kind of the volume 2 and 3 of his textbook coming out now, and he says that game theory is a branch of mathematics that says nothing about reality and can never be refuted. I might agree. I think I agree with it can never be refuted because of this flexibility in the statements, but I don't think it's just mathematics, because there is some common theme, and the common theme is extra mathematical. Put cooperative and non-cooperative game theory together. What unites it is not the mathematical structure, but the subject matter. So I think it's really hard to refute theories in game theory or in decision theory, because you could always come up with some interpretation that makes sense. And here, Mr. Tversky told me years back that, actually years back, he said that theories are not refuted, they are embarrassed. It becomes embarrassing to hold on to a theory. You could always try to salvage it and redefine things, but at some point, people just look at you and say, really. The last thing I would mention here are two notions of rationality. And then I'll try to wrap up and say what the common structure is. So the two notions of rationality have to do with, so basically everything here is subjective in the sense that I'm not defining rationality by some behavioral axioms, but I'm saying something is rational for a person if they feel comfortable with this decision once you expose them to the analysis. And over the years, we've sort of refined this a bit. So subjective rationality is a decision that you really feel comfortable with, that I cannot convince you you are wrong about being fair. Objective rationality is the kind of thing that I can convince any reasonable person that it's the right decision. So if I can try to convince you that you shouldn't smoke because it's bad for your health, I think that any reasonable person today should accept this sort of objectively rational decision. Forget about decision, at least to agree that smoking is hurtful, even though you could still argue that whenever an RCT, blah blah blah, but any reasonable person would agree with that. There are certain things that are more subjective. So this is another paper with David and Massimo Marinacci and Fabio Maccheroni. We talked about axioms in decision theory, analyzing them from this point of view, saying that the objective rationality axioms tend to be incomplete. Namely, there are certain things I can prove to you that this is the right thing, but I might not everything will be able to objectively prove them. The subjective thing is okay, you have to make decisions, so you have to have a complete relation at the end of the day, and it's subjectively rational if I cannot prove to you that you were wrong or silly about it. And then the last thing that we just mentioned is there are two ways to think about decision theory in terms of giving you the right answer in ways or just testing your arguments. So in this other paper, we basically provide a structure, and the problem with this this thing is that it's just very cumbersome. I mean, what we want to do is to describe the theories, and there is an act of the theories attaching some theory to reality, but you have to model both. So I'm not trying to drag you through this, especially that we run out of time. Okay, but the point there is to say that in some sense we could, and all these four distinctions are basically a distinction between universal and existential points. So what we have there is we assume externally some set of reasonable decisions. Okay, those kind of things that are not embarrassing in the language of Amos Tversky. Of course, we have no claim to try to model that. We take this as given. But we say that there are certain things that are reasonable. For instance, it is reasonable to think of the US as a player. It is reasonable to think of the United States president as a player. It's not so reasonable to think of the table as a player. So there are certain things that are given to us externally. And then the question is whether something is stated by the theory for every interpretation or only for some? So now when you think about the two roles of economics, when would I say that economic theory predicts that? Well, that would be true if I can say that for every one of the possible interpretations, the theory says this and that. When would I use it as a test of reasonability or test of coherence? I would say, okay, this journalist or this politician gave this prediction. There exists a way that this is coherent with economic theory, so I will not criticize it. I will criticize it only if there does not exist in a single interpretation that makes this prediction. The same would work with theories and conceptual frameworks. So if I would say that a particular theory that's very concrete, even if we take the ultimatum gain coupled with the assumption that utility is only monetary outcomes, then it gives you concrete prediction for every reasonable interpretation. You can say, here is an experiment. But if you allow yourself the freedom of what is exactly an outcome or what is exactly the utility function, then you say, well, there exists some things and the theory is not being refuted because there still exists some interpretations that can salvage the structure. Objective and subjective rationality basically the same. Something is objectively rational for every possible interpretation. You say that the same follows, so that's accept. And if something works for some, not to others, fine. So as long as there exists an interpretation that supports your decision, it is subjectively rational for you. And finally, for decision theories, they said that even the kind of thing that we're doing here in the first paper that I presented was to say, does there exist a probability or does there exist a set of probabilities? So I'm not saying that the theory necessitates something, I'm just saying you can defend the choice with the theory. Okay, my time is up and also my slides, so I'll stop here and take any questions.
Thank you very much. Any questions? That's perhaps the colleagues are still thinking. So my question is, let me have a question then. My question is a bit perhaps philosophical. So you mentioned Popper at one point as a classical science philosopher, but he had in mind the physics. And then at one point you mentioned Definetti. And Definetti already in the 30s warned the mathematicians that physics is important and you can use mathematics in the field of physics and you can get a lot of problems from physics, but social sciences will be very important. And it's true. So the mathematics and the mathematicians can import a lot of problems from social sciences. So why do we have, I also have this feeling that I have to meet the standards of physics when we speak about something. So when I think that we must be serious, then I have to compare what I do to what our colleagues from physics is doing. So what do you think about this? That we should think of application of mathematics in social sciences or in social science in general. It's better in a different way from physics, or we should use a standard canonical norms for all fields, which thinks that are serious science.
Well, unfortunately, I don't think we need necessarily mathematics. I think that formal models are extremely useful in the social sciences. But if you think about the natural sciences that are very successful and very helpful, not a lot of mathematics. But biology these days, you know, it's of course you do need analytical thinking. Formal models can be very helpful, but it's not like physics exactly in terms of the application of mathematics. So in this sense, I would say, mathematics is a tool. We personally could make the choice to work in a field that uses more of it or less, but I don't think it has to be part of that. But I do think that from the natural sciences, life sciences in general, there are some useful ideas. And I think that even though the received view has been, discredited in philosophy of science, I think this is overstated, widely overstated, because I mean, philosophy of science is a social science. Philosophy is a social science. So we cannot expect a theory in philosophy of science to be much more accurate than theory in economics. It's not physics. So if they come with a certain image of what is a good science, I think that we should think about it the same way we think about an arrow de Vermont. And as such, I think it's very, very powerful, very useful, and can tell us, what counts as a theory, what counts as science, and what would be, say, completely irrefutable. So the first approximation, I think it's very useful also for us. That's.
So thank you. So what I mean, for example, some years ago, I took part in a workshop, which was on one hand, decision theories from econ or social sciences, and the other hand, physicists. And it was very interesting that the physicists were not too interested in interpretations. So they have models, and they usually said in physics, shut up and calculate. So on the other hand, usually in decision theory, you have very nice stories and less calculations. So interpretation is very important in social sciences and less important in natural sciences somehow. So this kind of duality impressed me. So that's because that's the reason why I asked you that perhaps you think of these two fields as something which are really different. But yeah, this is only an impression, so no more for sure.
Yeah, I guess there is a continuum. So some philosophers of science would insist that physics is also, that you need auxiliary assumptions there when things are not so clear and not so. But how could we compare ourselves to them? So it's a huge quantitative difference, if not a qualitative one. But there's a whole gamut, and if you compare it to other fields, and where is psychology exactly, or neuroscience, and
yeah, but so sorry, and the last thing I remarked. So Popper itself is a very debated person, or his ideas. So this kind of predictability and falsifiability, which the main concept or the really core of his concept is a very questionable idea. So for example, if even in physics, if somebody is researching in the Big Bang at the beginning, this kind of predictability or this kind of stuffs are not too relevant on that field. So it's very, very speculative. So I mean, when we think that when we start with Popper, that for theory must be useful in a sense because we need predictions. Sorry for my son. Then we already biased a bit in this sense.
Yeah, but I think, well, first, indeed, you see that, among physicists, there is quite a bit of a rift, and many experimentalists are completely disenchanted with Big Bang theories and string theory and all kind of things that you cannot possibly ever test. I think it's a healthy debate. Again, it's a guideline. I wouldn't say that there is a lot of reason that you doubt if what you said can be tested and the energy that you can produce. But as a guideline, I think it's useful. And I also think that the examples that Popper gave, whether it's Marx or Freud or evolution for that matter, and even evolutionary psychology, these are good questions to ask. I think it's, is there anything that you cannot explain by this theory again? And sometimes I feel that, we just take very talented young students and we ask them, show them something weird and say, come, let's see you explain this with a standard assumption. But no, don't use any other tools. The rules of the game is like drawing a miniature. The rules of the game is that you're not allowed to put in any motion like this. I still want you to explain this as something perfect equilibrium. So we give them some kudos for jumping on this kind of hoop, which is sort of okay. But then the question is it saying anything? And I think it's an important question to ask. One of the things I'm trying to say here is that we could be useful even if we don't. So it's even if our role in society is only to clear up discussions and sharpen arguments, I think this is still something very useful. Even how much, how little we cost in terms of experiments. We don't need accelerators, and we don't kill apes, and we don't do many bad things. We just sit there with our laptops. So I think that we sort of earn our keep. But I do think it's a question that should be asked. Like, what have you done for us lately being the past 50 years? Not any individual. Okay, I would ask any student or any person, what have you done for humanity? We are playing our role in the equilibrium. But as a field, I think we should have an answer. So sometimes we could predict things, and I think there are some successes. Sometimes we could say, look, we prevented some sickness, but it could be other things. But I think it's a good question to ask. Are we doing anything for society? I mean, not on any particular paper, but as a field, from time to time. I think.
Okay, thank you. So changing IDs are the most important things, perhaps. So it's useful for many reasons. Yeah, thank you.
Thank you.
Other questions? I don't see, perhaps, from the audience. It seems not. And thank you very much.
Thank you. Thank you very much. Thanks for your attention.
Thank you, Tzachi.
Bye-bye.
Please.
Bye.
Happy holidays.